Hi everyone, I'm Navyata and I'm a developer advocate at Meta. This Build with Meta Llama video series demonstrates the capabilities and practical applications of Llama models for developers like you so that you can leverage the benefits of what Llama has to offer and incorporate it into your own applications. In this video series, we'll discuss some of the various ways in which you can run Meta Llama models and go over some of the resources available to you to get started. In this second video, we will learn how to run Llama models on Windows OS using Hugging Face APIs with another step-by-step tutorial to help you follow along. So let's dive in. For this demo, I'll be using a machine running Windows OS with our RTX 4090 GPU. Since we will be using Hugging Face Transformers library for this setup can also be used on other operating systems that the library supports, such as Linux or macOS, using similar steps as the ones shown in this video. Let's take a look at the steps. To allow easy access to Meta Llama models, we are providing the downloads on Hugging Face, where you can download the models in both Transformers and native Llama 3 formats. To download the weights, visit one of our repos containing the model you'd like to use. For example, we will use the Meta Llama 3 8 billion Instruct model. Read and agree to the license agreement, fill in your details, and accept the license, and click on Submit. Once your request is approved, you will be granted access to all the Llama 3 models. Our request was approved, and we now have access to the models. For this tutorial, we will be using Meta Llama models that are already converted to the Hugging Face format. However, if you would like to download the original native weights, click on the Files and Versions tab and download the contents of the original folder. If you prefer, you can also download them from the command line by typing pip install Hugging Face Hub, then type Hugging Face CLI download followed by arguments as shown. In this example, we will showcase how you can use Meta Llama models already converted to the Hugging Face format using transformers. To use it with transformers, we will be using the pipeline class from Hugging Face. It is recommended to use a Python virtual environment for running this demo. In this demo, we are using Miniconda, but you can use any virtual environment of your choice. Make sure to use the latest version of transformers. To do that, open your terminal and type pip install -u transformers upgrade. We will also use the accelerate library, which enables our code to be run across any distributed configuration. To do that, in your terminal, type pip install accelerate. We will be using Python for our demo script. To install Python, visit the Python website where you can choose your OS and download the version of Python that you like. We will also be using PyTorch for our demo, so we'll need to make sure we have PyTorch installed in our setup. To install PyTorch, visit the PyTorch website and choose your OS and configuration to get the command you need. Paste that command in your terminal and press enter. Next, open the editor of your choice and create a Python script. In our script, we'll first import transformers, import torch, and from transformers, we'll import auto tokenizer. Next, we'll define the model we'd like to use. In this case, we will use the 8 billion Instruct model, which is fine-tuned for chat. To do that, we'll type model equal to followed by the model name. We will also define the tokenizer, which can be derived from auto tokenizer based on the model loaded by using the from pre-trained method. This will download and cache the pre-trained tokenizer and return an instance of the appropriate tokenizer class. To do that, let's type tokenizer equal to auto tokenizer from pre-trained model. Now, we need a way to use our model for inference. Let's type pipeline is equal to transformers.pipeline, text generation, model is equal to model, torch dtype is equal to torch.float16, and device map is auto. Pipeline allows us to specify which type of task the pipeline needs to run, in our case, text generation. It specifies the model that the pipeline should use to make the predictions, specified by model. Define the precision to use this model, which is torch float 16, and device on which the pipeline should run, defined by device map, among various other options. We'll also set the device map to auto, which means that the pipeline will automatically use a GPU if one is available. Now that we have our pipeline defined, we need to provide some text prompts as inputs to our pipeline to use when it runs to generate the responses. Let's define this as sequences. Let's type sequences is equal to pipeline with the prompt saying I have tomatoes, basil and cheese at home. What can I cook for dinner? Do sample is true. Top k equal to 10. Number of return sequences 1. End of string token ID will be provided by tokenizer.endofstring token ID. Truncation is true. And max length is 400. The pipeline sets do sample to true, which allows us to specify the decoding strategy we'd like to use to select the next token from the probability distribution over the entire vocabulary. In our example, we are using top k sampling. By changing max length, you can specify how long you'd like the generated responses to be. Setting the number of return sequences parameter to greater than 1 will let you generate more than one output. Finally, in your script, add the following to provide input and information on how to run the pipeline. We'll run a for loop over the sequences and print the generated result. Now we have our script ready. Let's save it and go back to our terminal. We're ready to run the script, but before we do that, let's make sure we can access and interact with Hugging Face directly from our command line. To do that, first let's install the Hugging Face CLI using pip install -u Hugging Face Hub CLI as shown. Then type Hugging Face CLI login and press enter. Here, it will ask us for our access token, which we can get from our Hugging Face account under settings. Copy it and provide it in the command line. We're now all set to run our script. To run our script, type Python with the name of the script, which in our case is llama3hfdemo.py, and press enter. We see it downloaded the model, shows us the progress on the pipeline along with our question and the answer it generated after running the script. It goes over the list of ingredients I will need to make the suggested dish and with steps on how to make it. In this example, we saw how to run Llama models on Windows with the Meta Llama 3 8B Instruct model using the Hugging Face Transformers library. If you'd like to check out the full example and run it on your own local machine, our team has worked on a detailed sample notebook that you can refer to and can be found in the Llama recipes repo. In the Llama recipes repo, you will find an example of how to run Llama 3 models using already converted Hugging Face weights, as well as an example that goes over how you can convert the original weights into Hugging Face format and run it using those. A link to this notebook can also be found in the description box below. We've also created various other demos and examples to provide you with guidance and as references to help you get started with Llama models and to make it easier for you to integrate these into your own use cases. To try these examples, check out our Llama recipes GitHub repo, where you'll find complete walkthroughs for how to get started with Llama models, with installation instructions and dependencies, and recipes where you can find several examples for inference, fine-tuning, training on custom datasets, as well as demos that showcase Llama deployments and basic interactions, as well as specialized use cases. So here we are. We saw how we could set up Llama models locally using Hugging Face APIs with a step-by-step demonstration of how you can set it up yourself. If you prefer to consume information in a written format, we've also published a blog that will go over all the things we discussed in this video and more. The supporting blog can be found on our website and will also be linked in the description box below. In our next video, we'll see some of the other ways in which you can run Llama models and go over all the resources available to you to help you get started. We hope you found this video helpful to provide you with insights and resources that you may need to get started with using Llama models. Thank you and see you in the next video.